This is the first of a multi-part series on extensive documentation for Math Blaster in order to provide the community with additional information about how the game works. In this video, I'm going to be covering a basic overview, specifically this emulation mode reset function, which is essentially the top level management of the game from start to finish, and how that works. It's emulation mode reset because the processor in the SNES has two different modes, native mode and emulation mode. And in emulation mode, it is emulating a 6502 processor, which is the one in the NES and I believe Commodore 64 and Apple II and lots of other things. So I'm assuming that emulation mode reset is basically when the game boots or you reset the console. The first thing it's going to do, IDA has picked up that this is sound CPU communication, joystick interrupt, etc. As well as these first few subroutines that it's going to run are also initialization stuff. We've got VRAM modifications and initializing variables and stuff. We don't really get to the interesting part until here, because this is actually the loop that controls essentially an entire run through of the game from menu to menu. And we'll see this is the subroutine that actually controls the main screen. So where it, after it's booted up, when it starts playing the theme and there's the Math Blaster logo, that the subroutine does that. And then when it's finished running, there's two things that can happen from the main screen. Either you could do nothing and it would go to the cutscene, or you could press start and it will go to the settings screen. And so we can see how that's written here. There's a counter for frames where you have done nothing, and when that reaches a certain point, it will go to the cutscene, and then it's also checking whether you press start. So that happens inside here. And then at the end, this RAM address ACC is going to be set to either 0 or 1, depending on what happened. So 0 is user didn't do anything and go to the cutscene. So that's just going to happen automatically. Like when it reaches the counter, it will just break free and return to subroutine. But if the user presses start, which is detected right here, it will store 1 into ACC, and then the emulation mode reset will know to go to the settings screen next. So this RAM addresses 61 and 62 contain all of the user's inputs. It's just 1 bit per button. And so this words in this case are 2 bytes. So this contains both of those. And then it's ending it with this, which is 10, but it's 10 in hexadecimal, as indicated by the, I believe it's the $sign indicates that we're in hex addressing mode. So 10 in hexadecimal is going to be one particular bit of this word, and it happens to be the bit for whether the start button is pressed. So then it's going to branch depending on that. And it's in this loop. So it's just going to constantly check whether start's pressed. And if it isn't, then just advance an additional frame on the counter. So we know it's returning a 0 or a 1 into this address. ACC, and so this branch of not equal to essentially means that it's going to branch if it's not 0. So if it's a 1, which means the user pressed start, then jump over here and run this, which is the settings screen. But if it's not, then run this subroutine, which is the cutscene subroutine. So if we go in here, it's moving a lot of data into RAM, which I believe is sprite location and animation state information, amongst other things. And this is going to bring you to the settings screen where you can change number of lives and difficulty and controls and things like that. From here, in the settings screen, at the end, it's going to again check whether you're pressing start, which is right here. So we see it reading your inputs again and checking whether start is pressed. And then this is a screen transition, I believe. So when you've pressed start, it will fade the screen to black and start gameplay. So that's all managed inside of this subroutine. So by the time we get back here, gameplay is already going to be starting. So I believe a lot of these RAM addresses that it's storing the 0 flag to are ones that are managed by the settings screen. So the variables that store your lives and difficulty, etc., are here. So zeroing those out, and then we've got this, which I believe is handling. Yeah, I've got display control. So it actually tells how to use that, and so this particular value is turn the screen on with maximum brightness. So you're right, because the screen is off at this point, because it does a screen transition in between each menu, which is 15 frames of fading and then 15 frames of fading back in. And then after all of that's happened, we get down to this subroutine, 81AC81, which, as far as I can tell, runs the actual game itself. So by this point, we know that we want to enter the game. I won't go too much into detail about how this function works, but it runs throughout the entirety of the game running until the very end, where here it's checking inputs again, but this time it's not ANDing with a particular bit, it's simply exiting the loop if any of the buttons are pressed. And I've tested it, and I believe the only point at which that happens is the end of the game. So if you're on the credits, you can simply press any button and it will exit this loop. But that's how I was able to tell that I think this is manages all of gameplay, because basically called from the beginning, and then the end of the subroutine here is when the game's over. So basically what happens is it boots up, loads the main screen, either loads the cutscene or the settings screen, then runs actual gameplay, and then when it's done, this is actually in an entire loop itself. This will go back to here and put you back on the main screen. So this loop is essentially an entire run of the game. Well, mostly it's just menus in here, and then this is the actual game. And that brings us pretty much to the end of emulation mode reset. So looking at This routine in particular can provide a basic overview of how the game works. So once I know more, I can do additional parts exploring, hopefully actual gameplay next time. So I can try and figure out the mechanics of what actually happens when you're going into trash, and that will be for part 2.